Hi guys, and welcome to Magic. My name is Thomas Hansen and I'm one of the magicians over at servergardens.com, and in this video I'm going to measure the performance differences between Entity Framework and Hyperlambda. And I want to emphasize there's a link in the description of this YouTube video leading to a DZone article where I explain my rationale for why I tested the way I did and why I measured the particular things I actually did. Now, first of all, this is using MySQL and the Sakila database. If you don't have the Sakila database, you can actually create it using Magic. Simply go to the SQL menu item and choose Sakila and execute this script. I already have it, so I'm not going to do it. That's going to just simply result in an error. And then also the C# code here is going to be published at the DZone article, so you can reproduce what I'm doing here. I'm basically got a DB context with three DB sets, actor, film, and language, pointing into my Sakila database. This is the same connection string as you will find in your config parts for the record here. Let's see. In your Magic installation. So assuming you can get Magic up running, which only implies changing DB to localhost. As you're starting, well, actually that actually depends upon Docker, so it won't completely work. But assuming you can get a MySQL instance up running locally, you can basically reproduce what I'm doing here. Here's my connection string, of course. So here's the class actor wrapping my actor table. Then I have a class film wrapping the film table, which actually has two foreign keys, language and original language ID, which are the foreign keys that exist in that particular database table in the Sakila database. Then I have language here. Then I have three HTTP GET endpoints, foobar1 and foobar2. And foobar3, which are doing entity framework retrievals. I have created the equivalent type of code in Hyperlambda, where I'm doing the same thing. And yes, this looks a little bit weird. Why? Because I don't want to measure my network adapter. I actually want to measure entity framework. And since I have no means to actually invoke a Hyperlambda file besides actually creating an HTTP connection, the only way to adequately actually measure the performance is to use entity framework several times consecutively within a loop from within an HTTP connection, allowing me to get results that are comparable. So basically here I'm doing 50 iterations, creating Sakila contexts, retrieving all films where language equals name. This is a join, obviously. Then finally, the most important part is I have a change model here to an HTTP put endpoint that actually updates it actually loops through. And yet again, this is the same argument. I don't want to measure my network adapter or my database type, MySQL. I don't want to measure MySQL. I want to measure entity framework and Hyperlambda here. So I'm doing an iteration of 1000 here in updates, where I'm basically changing the description, adding the input models description here, appending a GUID.new GUID to string, and then saving the changes asynchronously. Both of these implementations are 100% asynchronous in nature, implying they're basically doing the same. So let's have a look at the HTTP put equivalent in Magic. Open up your browser or look at the video. Then let me find the modules, Sakila, and then multi, down here somewhere. Multi-update put. Here you see the equivalent Hyperlambda code. It takes an argument being the description. It iterates for 1000 times, basically every single record in my film database. Then it basically updates them one at a time. And it actually creates a new MySQL connection for every single iteration. I mean, obviously this is not optimal code. However, yet again, I want to measure entity framework and Hyperlambda. I don't want to measure my network adapter, and I don't want to measure MySQL. So that's the reasons why I've done it like this. So with that in mind, first things first, let's first check out entity framework on a simple get doing a join for language equal English on my films. As you can see here, it executes in 329 milliseconds If I do the equivalent in Magic here, then it executes in 193 milliseconds. That might not be a completely fair comparison though, because Entity Framework has a cold start requirement, implying the first time you use it and or a specific query, it takes more time. So let's do it again. Okay, now we're talking about 60 milliseconds, and here we are talking about 51 milliseconds. Still Hyperlambda being slightly faster, and of course we're going to be doing these tests multiple times to measure the relative performance difference. Here I'm doing into actors. I'm selecting actors with the first name starting with P. This is Entity Framework, requiring 26 milliseconds. This is Magic, requiring 30 milliseconds, roughly the same. If we do it again, you know, then we'll probably, okay, 18 seconds. 21 seconds, roughly the same. Actually, Hyperlambda is slightly slower here, apparently. Then let's do first name starts with F, 21 milliseconds. Then let's do the same for Magic, 19 milliseconds. Then let's do the foobar 3 thing. Yet again, let me emphasize, foobar 3 thing is the thing that's actually looping. So it basically loops 50 times, retrieving the first 10 records from film where language referential integrity points to language table where the name equals English. Okay, send takes 613 milliseconds. The same equivalent for Hyperlambda is 628. If we do it multiple times, maybe we'll get slightly more similar numbers. However, here comes the kicker. The put part. Now, before I execute this, let me go into my SQL and demonstrate a little bit of a thing here. You see now, if I select all records from films here, you will see they are prepended with Magic and then a random GUI ID. So let's execute the Entity Framework bugger here. And as you can see, it actually is insanely slow. Why? Because of Entity Framework's inherently bad architecture. Sorry, there's no way to say this out politely, so I'm just going to say it as it is. 10.89 milliseconds. If we do the equivalent in Hyperlambda, we see here, and I've got QuickTime running for the record, 3.95 milliseconds, more than twice as fast. If we try to avoid the cold starting of Entity Framework, okay, let's execute it. We're still looking at 8.78 milliseconds. We do the same for Magic again. We're looking at 3.42 milliseconds. If I now, of course, select all records here, you'll see that every single record starts with Magic. If I execute the entity version bugger, and I do select in MySQL Workbench, you will see that every single record starts with the Entity Framework, having a GUI ID prepended to it. Once it's done. And now it starts with Entity Framework here instead of Magic. Now, yet again, people will probably argue that this is not a relevant model. Actually, I would counter argue, saying this is the only relevant model for testing. Why? Because yet again, I don't want to measure my network adapter. I don't want to measure MySQL database instance. What I want to measure here is entity framework. And what I'm doing here is that I'm basically looping from 1000 to 0. Then I am selecting that record, having that ID. Then I'm changing the description of that particular record, and then I am applying context.save changes async. Yet again, my rationale for doing the test this particular way is explained in the article, which I'm linking to in the description of this YouTube video, pointing to DZone. Now, why would you want to select the record? Well, actually, you know, every single entity framework application I've seen in my entire life either does this or some permutation of it, implying it's got a view model doing automapper, automatically creating, and etc., etc. And this is extremely expensive code, even though if I don't even select the record, if I transform using automapper from my view model into my database model, because it uses reflection, increasing my CPU time, etc., etc., etc. So basically, entity framework and all ORM libraries, at least those that I am aware of, including in Hibernate, basically results in suboptimal code, where this piece of thing here, which actually selects my record first, while if you look at the equivalent for Hyperlambda, multi-update, you will see here it doesn't need to select my record. It doesn't care about my record. Now, why? Because entity framework, of course, is an object-oriented model, implying you want things such as my object.save or context.save, as I'm doing here, right? Now, this model of using your database, where you arguably are trying to force your RDBMS system into becoming an object-oriented thing, results in this type of code. I can guarantee you look at the average entity framework solution out there, it is some sort of permutation of this particular code. And I do realize it is possible to do partial record updates without selecting them first, etc., etc. However, for all practical concerns, those features are barely used at all. So what we're looking at here when I'm showing you 10 seconds is actually quite relevant. Yet again, this code takes 10 seconds to execute, entity framework. Well, 8.45. This second magic code takes 3.5 seconds. Same logic. Same code. So now I've collected, I've got two collections here, testing entity framework and testing magics. Let's measure their average consumption, the way you could assume they would end up working in your end app by running this collection 10 times. Okay, now I'm running the entity framework version, and I'm going to be using my calculator on my iPhone. And then I'm going to start my stopwatch exactly as I click the button, and now I start my watch, and then I'm looking at 10 iterations of this running. I'm on second iteration. Of course, QuickTime is using a lot of CPU on my computer now. It was slightly faster earlier. But basically, this is the type of performance you can actually expect. And now, of course, if we had Visual Studio running this, and I don't have Windows, so I can't actually look at this myself, and you open up the profiler for Visual Studio, what you would see actually is an insane amount of CPU time. Why? Because of all the bad attempts at trying to make a strongly typed programming language such as C# become dynamically capable of tracking changes to your database and updating them, etc., etc. So if we did, and yes, we're looking at 56.77 seconds. That was the entity framework version. 56.77 seconds. Let's do the equivalent with magic here now. Run. And let's do 10 iterations if my computer has any more CPU and memory left. That is, and I'm starting it now. And after 13 seconds, we're halfway through, implying this is going to probably end up at 30 something. Let's wait until it finishes. Yeah, 27 seconds. Implying in a heterogeneous environment where we're actually using this thing, Entity Framework is actually twice as slow as Magic. And yet again, these tests might not be completely the way other tests are done, because I'm looping through 1,000 invocations here. I'm selecting a record and then saving it, and etc. etc. However, what we actually want to measure is not the database. We don't want to measure the network traffic adapter. We don't want to measure MySQL database type. We want to measure Entity Framework and Hyperlambda and compare these to each other. And what we see is basically that Hyperlambda is twice as fast as Entity Framework. Yet again, there's a link in the description of this YouTube video to a decent article where I'm publishing the code, allowing you to reproduce it for yourself. Thank you for watching. Have a nice day.